3, 2, 1.
Hey, good afternoon, everybody. Thanks for joining in. We've got a pretty good conversation on tap for the day. Today's Lunch and Learn topic is what app devs need to know about SQL data development. Hi, I'm Preston Mesarvey. I'm a principal data services consultant with Improving, located in one of the Atlanta offices. What we're going to talk about today is basically some of the gotchas, some of the things to look out for if you're, not spending your day-to-day in 100% data engineering or data development. Just some things, some tips and tricks to kind of help make those moments when you do have to craft up a query or, have some SQL queries in your app code behave within the realm of good performance. So I've got Justin with us today. He's going to help moderate. So if you have any questions, let's just kind of keep this, kind of a nice little informal, comfortable conversation. If you have questions, feel free to reach out in the chat and we can go ahead and have those answered in time. No need to wait till the very end. We've got a lot of stuff to cover today, so let's just go ahead and get into it. Like I said, we're going to be looking a lot of times at code that just doesn't really adhere to best practice in the SQL development world, anti-patterns, if you will. Consider this, anti-patterns greatest hits, things that we've seen out in the real world within code bases that we've either inherited or that clients have brought us in to kind of help augment some of the top offenders is what will be making up this presentation today. So let's start with the basics. When I first started my journey with data development, data engineering, I found a really nice group of people in the local data community. But it seems like there was a common theme to all of the initial presentations on some of the intro into data, beginning data development courses. There was a common theme around select star. We're all guilty of it. It's fast, it's easy. If you just want to do ad hoc querying, you don't have to call out those columns by name. However, when we're promoting code to production, that's where things change. We want to make sure that we're only calling out those columns that we really need to use. Basically, the golden rule of thumb is with SQL Server is you want to retrieve the data, get in, get out, and free up those resources and those cycles for some of the other jobs that are waiting for the SQL instance to perform. So, like I said, while SQL Star is completely fine for ad hoc querying, troubleshooting, what have you, not saying never use it, but when we are looking for mindful code that is going to be run in a production environment, let's just make sure that we're calling out those columns. That way we minimize that footprint of data and only get that data that we really need for the application. Another caveat to that is, when you are minimizing your data footprint, you are minimizing the actual, lock and load time for those tables. So the default nature of SQL Server is when you, execute a query, there issues a table lock. So if you're not necessarily needing to retrieve 100% of the data, your footprint can be minimized by only selecting just that certain set of columns that are needed. If anybody's ever used Entity Framework, you'll notice that that's a tool that is in its own right. It has some opportunities. It allows you to create modeled queries very quickly and effortlessly without really having to get in and manually do a lot of data engineering work. The alternative there, or the caveat there, is that a lot of the behind-the-scenes queries that the Entity Framework makes can be really kind of greedy, if you will, very superfluous in what it's doing. You'll notice if you ever look at an Entity Framework query, if it's doing something like a simple join, it doesn't look like something that you would write yourself. I think it's a little bloated at times, but it serves its purpose. It allows app developers to quickly bring in SQL data queries into their code without really having to touch the data knowledge aspect of it. So just something to keep in mind. Not saying don't use an entity framework, but if you ever come across a scenario where you've got a slow query, a slow report, or anything like that within your application, if it's an entity framework query, chances are if it's heavily processed or there's a lot of business rules in there, you could probably tweak that by making your own stored procedure. I'll go ahead and just pause here. Any questions regarding that? Like I said, if you do have questions, we're going to go ahead and continue on, but Justin, just let me know.
None so far.
Awesome. So let's start at how SQL Server really takes the query and breaks it up into chunks and actually does what it's supposed to do. There's an actual execution order. We all remember our days back in grade school doing, addition, subtraction, multiplication, parentheses. There was a common rule that you had to do in order. PEMDAS, I think, is the acronym of choice there. Well, SQL Server, unfortunately, doesn't have a nice acronym to kind of help memorize this, but it kind of operates the same way. There's an order of operations. So if we take a query, these are at least the most common 8 steps that it does in order. If you look online, there are more exhaustive lists, but just for the sake of this conversation today, we're just going to keep it simple and look at some of the more common SQL clauses here. So naturally, number one, the first thing we need to do when we execute a query is, what is this data that we're actually querying? Where is it coming from? Is it related to any other table? So maybe you have like a person table and, maybe an address table. So if we're using that as our data set, that's the number one operation. We're actually identifying and calling out where this data resides in the database. So that's step one. Step two is your where clause. Do we need to filter that data down by any means? Is there like a certain flag or something, or is there a certain attribute that we just want to omit most of the records and target just a nice subset? So 1 is from and join, 2 is where we filter that down. 3 and 4 is where we can do group bys and halvings. Those are your aggregation clauses in your query. So if there's anything that is summing up detail to give you, a min or a max or a sum or an average, that's where 3 and 4 come into play. Most queries, if they're not doing aggregations, then we're skipping 1 and 2 and then really going down to 5. Just your basic query, select star from table where column A equals some value. That's 1, 2, 5. Those are the 3 major steps that SQL Server is calling the engine to do in that order. Now, where this comes in handy is when you're starting to craft your queries. If you say that maybe I only want the top 1 query or top 1 query results from this table. Conversationally, you think, I'm only bringing back 1 record. What's the big deal with top 1? But if we look at this order of operations list right here, you'll see that top as a statement in your query, well, that's actually one of the last steps that it has to do. So if we don't have to select top, but we're doing it anyway for some logic or to obtain some value, we have to ask ourselves, is this really the most efficient way to get this? Now, a lot of times if you're working with small data sets, this might not be something that's visually a performance problem, but as data sets get larger, as queries start becoming more and more the call volume of these queries start becoming more and more, that's where these little tweaks will start showing some performance pains. So just kind of keep that in mind. You'll see that that's a common theme for today's discussion is even though it looks good on sample data, when we start to think about a larger data model or a more frequently called query set, we need to kind of think of what this does to the actual SQL Server engine. I just wanted to call out 6 and 7 also, distinct and order by. Distinct naturally is if you just want unique values. Sometimes you can't help it. Sometimes maybe there's a question of maybe we need to, tweak the data model itself a little better so that we don't have all these extra rows to actually roll this up. Another common theme of today's conversation will be it depends, because there's really not a single answer or a silver bullet to a lot of performance issues. You really have to ask bigger questions and better questions around what the data is trying to do and the business rules that are asking that data to do certain functions. We'll come back to order by. You'll see that later on as one of the performance pain points that I personally see in a lot of code bases that they don't need to be there. So we'll come back to that one.
Got one question for you.
Yeah, absolutely. Let's hear it.
What do you recommend, a good query or a stored procedure in terms of processor time or cost in the database server, and why?
I don't think that you're gaining too much by leaving them isolated. I think to the engine, it's really the same thing. I personally like the stored procedure just because it's now an object in the database. When you're using your repo, you don't have to, search for specific SQL code in the midst of, a whole big class of code. It's very compartmentalized, so that procedure can do, its own job. Another huge aspect on that beyond just personal preference naturally is just code reusability. If you've got a SQL query that you might need to perform multiple times, well, it's a lot better just best practice wise just to keep that in a stored procedure. So down the road, if that logic needs to be changed, we're changing it in one place and not 15 other places out into the code base. That's a great question. Thank you. So I said that we were come back to order by. So let's take a look at what we're actually doing here. We already know that order by is a very expensive operation in the context that SQL Server has to do a lot of steps in order to get to that. Well, SQL Server as a resource is expensive, relatively speaking, when we look at license costs and hardware and stuff like that. If we're forcing SQL Server to do work that maybe some other process or some other application can do, then let's utilize that. Let's not let an expensive SQL Server instance spend cycles doing work that a cheaper instance could relay. So let's give an example here. I've got a simple query. This is we're just going to call this a reporting query. This looks very similar to something you'd see either used in Power BI or used something in maybe SSRS, or maybe even the application is using this to call this information back to screen. So we're selecting a set of names. I'm sorry, my lights went out. I'm going to do a little move here so that I can get my lights back on. But that didn't work, so we're just going to do this the day the lights went out in Georgia. Okay, no worries. We've got a query here. We've got basically it's an address demographics type of a phone book query that the application is calling, maybe like a contact page or something like that. We've got a select statement. It's getting all of our relevant attributes, the names, the addresses, the locations. We've also got a format function here that's formatting when the last time it was this contact was updated. Format, that's a native function, not a huge cost, but if we look down through the query here, we see that it's joining up on a couple different tables so that we can get these desired attributes. But at the very end, we are forcing the order to return back to wherever this data is going. Like I said, it could be a website, could be an SSRS report, it could be anything. Well, we're forcing the order by last name and first name. So SQL Server actually has to do that work before it can send the data. Well, if it's going to a website or it's going to a page or a report, let's take the load off of SQL Server and actually have the UI layer do that ordering. Speaking from a reporting instance, maybe you've got an ordering option on each column so that if you've got a long list of contacts here, maybe you want to sort by last name, you click on the column. Well, that just throws away all that work that SQL Server did ordering this. That way, when the UI, it has more flexibility to do your ordering. You can order on state, order on date updated. So just something to be mindful of. Like I said, it's that does not mean by any means that we need to go through and take out all ordering out of SQL Server. But when you do start getting complaints, when you do find stored procedures or queries in your code that maybe they're taking too long, ask yourself the question: does this truly need to be ordered? It may not be. So something to keep in mind for sure.
Got another question for you.
Yeah, absolutely.
What is the best option for versioning in SQL? Sometimes that's the reason many developers use more entity framework rather than SQL procedures and queries. What's your opinion?
Now, are we talking on versioning of code or actual SQL Server versions?
I assume the SQL. Well, it could be code. I'm not sure.
Okay. Well,
Gabriel, do you want to clarify?
We can speak to both of it, I guess. So code versioning, I mean, if you're adhering to best practice and all of your code is stored in your repository, that pretty much is your versioning. You really wouldn't treat it any different than you would your regular code. When you've got databases, those can be wired up if you're using Visual Studio to add that project into your repository so that you do have iterations of code. I think that's what you're asking. I do see, unfortunately, a lot of businesses out there that they have all their other code, their website code, their middle tier code. All of that is in the repo, but when it comes to the database, it's kind of like the only thing out there that just doesn't have any versioning to it, because what's in prod that's the latest, and if something needs to change, there's no deployment process, but it's like a manual update this procedure. That's kind of a holdover from back in the day. There really weren't any good integration tools with your data engineering IDEs into a repo, but that's not the story today. Any database out there that's got stored procedures, functions, and any saved queries, views, even the schema itself, you definitely need to have that in a repo so that you can apply that versioning. Gabriel, if that didn't answer your question, feel free to ask another one later and we can follow up. Thank you. So let's talk about join practices. When you're first learning joins, I'm sure everybody has seen that Venn diagram over to the right. It's a favorite of mine because it gives a great graphical representation as to what this set-based join criteria actually is. We've got a table A, we've got a table B. What is that subset of data that we want to see? Is it an inner join? Well, that means that only the related records between the two, well, that's what we're going to see. There are differences between joins. Predominantly the most popular ones are the inner joins, your left joins. There's a cross join that's not necessarily pointed out here, but that's a Cartesian product. But for the sake of the conversation today, one thing I want to point out, because I see it a lot, is left joins are easy because it gives everything from table A, and if there's a match from table B. That's a lot of work. That's kind of expensive. If your business rules basically look for related values between two objects, two tables. So if we got an A and we've got B, and you only want the intersection, you only want those related records, don't use a left join and then do the filters to make it a valid subset of data. A left join does a lot of work. It does all the work of an inner join, plus it has to find those unmatched values. So I've seen cases where I open up a code base after we inherit some stored procedures, and just the default nature is just left join everywhere. So make sure you're asking the right questions of the requirements and the specifications. Are we looking for related subsets? Are we looking for unmatched? Because your joins do matter here. Another anti-pattern that I see is just really overly complex join criteria. Sometimes you can't help it, but you really have to ask yourself, if you're doing a lot of data gymnastics to get these tables to join, it's just not efficient. We've got to find a better data modeling practice because it just doesn't scale. And what I'm talking about here is I'm talking about overloading your join criteria with functions like, maybe the business rule dictates something like, if it's this value, join it. If it's not this value, join this. So joining on case statements, joining on things like coalesce, while you can do it and it's not, ultimately going to bring your server down to, severe agony, it's just one of those things that you should be mindful and ask, hey, we can probably make this more efficient if we augmented the data model this way. Something to keep in mind, like I said, it depends. Everybody's data model is different. Everybody has different sets of requirements. So force the conversation. Just ask yourself when you see, a 1,000-line long stored procedure with really complex join criteria, all of this order by logic, ask the question. It's like, what is it we're really trying to do? That way you can kind of compartmentalize the logic and, find those efficiencies where available. So probably the biggest offender that I see out in the wild for performance issues are loops and cursors. Cursors is another fancy name in data speak to basically call an iterative process when we're looping through a batch of data. So sometimes this cannot be avoided, but one thing that I want to point out is that I think it's overkill. I see it used so much that that I really want to point this out. A goal today is, if you can find one thing that you can take back and use as a new tool or a new mindset, then this is a successful presentation. And a lot of times it comes back to this slide right here, is trading loops, an iterative process, row by row, for something that's set based, a one-time transaction. That's that I see that so many times on so many ill-performing processes. A lot of times I see it in financials where you iterate over a process and then you take the output of that iteration and then you iterate again to get something else. It works. I get it. It's it's logical to read, but if you really dive into what SQL Server has to offer with the T-SQL language, you can see that there are tools built in to achieve a lot of those same goals a lot more efficiently. So let's take a look at one right here, the Recursive Cte. If you haven't heard of CTEs, basically what it is, it's a common table expression. That's what CTE stands for. Think of it just as a subset of data. Perhaps maybe you've got a series of records that you want to call a data set. Other things that you want to join to that could be tables, could be views, but we've got specific logic here in these 100 records. That's our golden data set. Well, you can wrap that in a CTE, and of course I'll show you an example of what that looks like here. But there's also the notion of a recursive CTE. So let's take a look at an example about what loops look like in SQL and how they can be made better. So I've got an example here, and we're going to go through a couple examples of different types of loops that I've seen. Here's our current requirement right here. We've got a table called person.person. This is the AdventureWorks database. It's a sample database available to everybody from Microsoft. So everybody has access to this if you just want a kind of a nice database that's already pre-built to play around with. We've got this table. It's the person.person table. Our goal here is to change the person type for every one of these records that have a match in our new person type update table. So I've created a new table here, and I've got a key value pair relationship with all of these business entity IDs, and I want to update whatever their current person type is. I want to update this to this new value. So this is a common task that happens in a lot of businesses where, hey, the database is not synchronized, it's got to be updated. I'm going to give you a spreadsheet. Here's what these values should look like. So we input that spreadsheet, we use it as a join table or a key value pair lookup, and we're able to update that data as needed. So one way to do this, and it's by no means the recommended way to do this, is to use a loop. This is a very simple, very crude example. of what a loop does in T-SQL. We've got our, our while statement here. We've got a counter. We've got a termination. It's got to be less than or equal to the max of the business ID from this target table, and then we're going to increment it as such. So through this loop, it's going to iterate through each record, and every time update the record where we get the person type from the test person type table where the business IDs match. So naturally, logically, this will work. This is a way to update data. But as you can see, this table, I think, has 2,000 records. It's not a lot of data, but what this job is doing is it's iterating over, looking up values and going through row by row by row. I even got it notated out here, row by agonizing row, RBAR. That's an acronym you'll see out on SQL blogs and stuff like that, just to kind of discourage this type of behavior. I'm going to go ahead and just stop this. This is not a good use of time here. But as you can see, one row updated, one row updated, one row updated, one row updated. We come back here. Okay, well, it at least did some work. They were all EM as a person type previously, and now they are going through and at least updating the values. But as you can see, that was kind of expensive. That took a long time. Now, granted, this might be a one-time thing, so however long it takes isn't super critical to the business. But think about if this was a piece of code that was promoted to production, where you're always updating. You're trying to synchronize data from one table and another table. Let's take iterations completely off the table. Where SQL Server really shines is where we do set-based operations. So what we're going to do here is we're going to update the entire data set, the entire target data set. We're going to join it on what we want to update with, which is the test person type table. And we're going to update the existing person type with the new person type based on the relationship in our augmented table here. So let's just go ahead and just run this. You'll see how quick it runs. And it's almost instantaneous. So yeah, 20,000 records. And as you can see, it's set base. That's one transaction, and all of our records are now updated as needed. That's a very crude example. I'm going to venture to say everybody on the call today probably doesn't utilize this as a design pattern, but I just wanted to call it out just because it is an easy example and that I have seen it out there in the wild. So if you do see something like this and it's a repetitive task that's done daily, weekly, monthly, quarterly, whenever, just note that you can, decrease the amount of time it takes to do that. And the reason why that's important is that even though it's not causing the business any pain, hey, the job is running in an hour. That's not impacting the business. But let's kind of take a step back away from the code and let's think about this from an architecture standpoint. If we're promoting all of this to an Azure database, well, that's a lot of consumption that Azure's gonna bill for. Azure bills by consumption and usage. An on-prem box, it's not going to cost you any more time to run a long query versus a short query, but the game has changed a little bit. Azure is a different billing model, so just something to think about. Let's take a look at another example here. And this is the CTE example. So I'm going to create just a temporary table here. And let's take a look at what this table looks like. So I've got an employee table. I've got 9 employees with first name, last name, and also which manager ID they report to. So if you've never seen a CTE, it's basically this subset here called out as an actual data set that you can use in your query, and you can treat it just like a table. So with a recursive CTE, what we're going to do is note that we've got multiple components within just this single SQL statement here. We've got an anchor member, which is the very first record in our employee list, and that's the CEO. That's an employee level. What the example is going to show here is how to build a hierarchy. And this is a very easy example that you can use to kind of get familiar with recursive CTEs. Where the recursive part comes is this bottom section here where we have this recursive member. We are interjoining the CTE to itself based on the criteria on manager ID versus employee ID. So real simple example. I'm just going to go ahead and run this just so you can kind of see the nature of how this code pattern operates. But basically, if you were wanting to build a hierarchy sheet of anything, really, I'm using employees as an example here. We can see by employee level which employees fit in which hierarchy level. So a recursive CTE is a great example for that. So anytime you see, you need to build hierarchies in your code, or if you need to do repetitive iteration based on calculated values, which we're going to see in this next example, this is where recursive CTEs really become a powerful tool in your tool belt. So let's take a look at this. This is another example here. I'm going to create a table, and we're going to use just some simple math, some simple account balances here to kind of illustrate the point of what a recursive CTE looks like compared to a loop. So I'm going to create a temporary table called account balance. Okay, I'm going to insert a single record into account balance. So I've got a month ID and I've got an ending month balance of $100. Well, what I want to do is I want to traverse over a series of months, and I want to apply interest. We've all done this in our real life, either our savings accounts, car loans, whatever, anything that accrues interest, it accrues on a specific cycle. We're going to go really aggressive here and accrue it monthly, but that'll help illustrate this example with this data here. So let's take a look at how we achieve this in a loop. So we're going to declare our interest at 5%. We're going to throw this out for 50 months. So basically what we want to do is add no more transactions into the table. We're not depositing any more money. We just want to see what that initial $100 looks like after 5% interest gets accrued on it every month. So I'm going to insert into account balance the ending month balance plus the interest of that balance as the new month. So let's take a look at that. This is the loop method. And we see here we've got somewhat of a, I guess you call these an amortization table for lack of a better term. But you see 50 months here, and at the end of the 50 months here, after 5% keeps compounding, you get a little over $1,000. So we did that with a loop. As you can see, it was a small data set, so it really wasn't doing any performance impact there. But when you start getting more complex examples, it starts to show its limitations, whether you're operating on a larger set of data or a larger set of business rules. So let's do this again. I'm going to comment out my loop, and I'm going to replace it with a recursive CTE. Same situation. I've got an anchor member here. That's my first month, and then we're going to recur each month after that with the interest. This is a set-based operation, and then we're going to insert that instead of row by row. We're going to insert it all at once into our table. So let me drop my table, create it again, and insert my new record. So starting back at where we were, $100. I've got my loop commented out. So I'm going to declare the interest, and I'm going to declare my CTE. And when we run that, we get the same results. It's just a lot more efficient. It's done within a set-based operation and not a row by row iterative process. So I know that was very quick. That was very simplistic in nature, but the key takeaway here for this portion of the presentation here is just if you see something iterating over and over again over a data set, really dig into that, really look at it and say, hey, does a recursive CTE make sense? And if it's a performance issue, you'll notice that, yeah, a set-based operation sure beats an iterative process every time. Any questions there? I know that was kind of a longer topic.
None at the moment.
Okay, excellent. So let's talk about another row by agonizing row situation, and that's scalar functions. So what are scalar functions? Scalar functions are simply a value that either inputs a value and returns a single value, or just doesn't input any value and returns a single value. So the reason why these are kind of a red flag scenario is just because of the row by agonizing row nature of the way they operate. So let's take a look at scalar functions. So I've got a scalar function here, which is basically get new stock. I'm on the AdventureWorks database. I'm going through the product table, and I'm using this function to basically look at another table and get me the stock, the quantity on hand of that. So when I run that, this is a large-ish table. You'll notice that we've got some time. It takes 10 seconds or so, 10, 11, 12 seconds, but it does return back what we want. Well, just the nature of this query, it looks simple, doesn't look complex, but behind the scenes, what it's doing is that it's calling this function every row that is a part of this data set. So again, iterative processes versus set-based operations. Set-based operations will always be more performant. So how do you create a scalar function with a set-based operation? Well, it's a different type of function. SQL Server has what they call table-valued functions, which are basically sets of data that return back kind of the same logic that a scalar function would do, but you can actually perform set-based operations on them via a cross apply, which is kind of like a join. So basically, we're achieving the same task here, but we're doing it in a join pattern. We're cross applying the data from the product table, submitting the product ID, much like we were in the scalar function here. We're submitting it to the table valued function here and getting the same results. This query does not take 10 seconds. It comes back almost immediately. So let's just take a look at the under the covers here and see what these two look like. So I'm going to go into programmability. I'm going to go into functions, and I've got scalar functions, and I've got my table valued functions. So if I'm looking at user function get stock new, I see it right here. It's pretty easy. It's working just like it said it would. It would, it's looking at the product table, the product inventory table, looking up the product ID, and then returning a value. Same thing. Where the table valued function is different is that it returns a table set. So you're actually able to just utilize it as a data set object. Hence why we had to cross apply on it instead of calling it out as an individual function in the select clause. So again, this does not mean to convert all of your scalar functions in your current database to table valued functions. That's not the goal here. But what we are trying to illuminate is that if you have an ill-performing query and you see that we are blasting scalar functions through all the select statements, and it's considerable amount of time, then what we'll want to do is to kind of see if there's a more efficient way of doing that. Another thing about scalar functions is that it's a serial operation. It's not allowed to take advantage of parallel processing. So if you've got some huge, 30-core server, when you run a scalar function on it, it's still only going to use that single core. So that's kind of a misconception there. You think it's operating a parallel, but unfortunately it's just not. It's just not the way they're engineered. And when you look at the execution plan on these within a query, a scalar function shows it's 0%, so it doesn't throw any red flags. Just to kind of illuminate that, I'm going to run this again with also set statistics IO on, set statistics time on. And if you notice in SQL Server Management Studio, up here is include actual execution plan. So I'm going to click that, and I'm going to run both of these queries. Now, again, unfortunately, that first query took like 10, 12 seconds to run. That second query was a lot faster. But what this execution plan is going to give you, it's going to give you a graphical representation of what's happening with the query, how the SQL instance is actually optimizing it and actually performing it. So let's take a look at it. You'll see here that we've got execution plan as a tab. You'll notice here in messages that we've got some extra data because we also set statistics IO on and set statistics time on. This is also a good tool to have if you're measuring queries because it gives you a lot of robust information on timing. So if you're performing one query, you hit the time on it, you think you want to make some performance adjustments, you run the time on it again. If it was a considerable change, you should be able to see that. But let's take a look at this query here. Now, right off the bat, I've got a lot of misinformation. I've ran 2 queries, and it's saying the bottom query is taking 100% of the job load. Well, we know that's not true because when we ran it, the first query took a lot longer. So these scalar queries here are showing it 0% of the work. So it's a little misleading here. You really have to be careful when you've got a lot of scalar functions when you're talking about performance because they just don't show up in the execution plan like you think they would as an indicator. Execution plans, if you haven't looked at it, really add that to your tool belt. If you're an app developer and you want to kind of see how queries are measured in terms of performance, if you're able to read an execution plan, you can really hone in on ill-performing queries. And when you get good at seeing what these objects do, you can kind of immediately target what the pain point is here. For example, this one's got an issue here where it says it could utilize an index. Maybe that's something we want to think about. Maybe it's not. All questions where it depends. But yeah, if you've never looked at execution plans, that could be a whole 1-hour conversation in and of itself. But if you can kind of look at the basics on it, it's there in SQL Server Management Studio, and it gives you a nice tool to kind of help view how your performance is running on your queries. So another thing, again, common theme, iteration versus set-based. Inline subqueries, that's another thing that I unfortunately see too many times. If we take a look at what that is, it's kind of lazy programming, unfortunately. We're adding a column, but instead of an actual column from some other table, we're adding a complete subquery as that column. That's expensive. Take the time. Find out what the join criteria is, identify the relationship, and it just, make it a join and add that secondary column from the other table. You don't have to create a completely new query inside of a query. That's expensive. Just to kind of give you an idea of how expensive, let's go ahead and, now you guys are familiar with where the execution plan is. Let's go ahead and just run this. And you can see the top query is a lot more expensive than the bottom query because the top query is doing that inline iterative row by row process, whereas the bottom query, it's a complete set-based operation, a lot more performant. All right, union versus union all. This is a common conversational misconception. Typically, when you think of unioning 2 sets together, conversationally, you just say, hey, I need to union these 2 sets together. But in T-SQL, there is a difference between union and union all. It's important to know what those 2 distinctions are. If we're using union, what that's doing is it's doing extra work because it's bringing in both data sets, but only returning the distinct values from those 2. Whereas union all, if there's a record in column or in table A and you're unioning table B and they're duplicate, both records will show up in your end result data set. So something to be mindful about. It's also something that kind of champions the conversation of, hey, what is it that the business needs to see? Do we need to see distinct values? Should this table have duplicate values? It just depends on the data. Doesn't necessarily mean that all unions are bad. Sometimes they're necessary. So it's, again, it depends answer. So sargeable, which stands for search argumentable. What we're doing here is we're utilizing indexing. So if we're doing a query and we're doing a where clause on a specific column, if that column is indexed, that's a covering index, and it's able to cover that query. So anytime you add an index that supports a query, your query is more performant than had it not had that index. what you want to try to avoid, again, is the row by agonizing row table scan. So if you're doing a, where color equals blue and that color column isn't indexed at all, well, now we have to table scan to find which rows equal blue. Let's take a look at this real quick, an easy example. Is something like this. We've got our person table. We're looking for all last names that begin with A-N-D-E-R. So Andersons, Anderton, all of those. Let's take a look at this. This is an index seek. Let's go ahead and run that. And it worked as advertised. We've got all of our people that have the last name of Anderson, Anderson with an E-N, all of those records are showing as needed. But this is a completely different query. This is looking for a wildcard before the A-N-D-E-R. So we're looking for rows now that have Granderson or Baranderson or anything that comes before that has this value. So if we look at that, Alexander, that's another one. The difference here is that this is sargeable because it's able to utilize an index. If last name is indexed, then we're able to go right to the A-N-D-E-Rs and bring back all of those records. Last name is indexed here, but this query is still not able to utilize that index because we're looking for components of that value that are preemptive of the index. We're not indexing anything in the middle. We're only indexing what that text value says. So if we look at that and run the execution plan, we can see plainly here that the first one is a sargeable. It's index seek. It's going right to the values. The other one has to search through the entire table with an index scan to go through and get all of those values that meet the criteria. That's a very crude, simple example. Something that you might see more often or more readily in a code environment would be something like this. Take, for example, we've got a sales table here. And the business wants, I need all sales that happened in the year 2011. Well, we're going to use the date part on the order date and get 2011. That's all we want, just 2011 dates. Well, unfortunately, that's a table scan also, because now the index has to bust apart every one of those dates and parse the year out of it. So while it looks clean, while it determines the results, it's fine for ad hoc, but if it's going to, if we're promoting this to prod, it's not as performant as it could be. We're not utilizing the index. Whereas this one, if order date is part of the index, then what we're going to do is we're just going to do a between value. This is the same specification. We're only getting sales orders in 2011, but when we run this, it's performant because it's running an index seek because we're running a sargeable query. We're able to take advantage of that index. So keep an eye out for that kind of stuff because filters can kind of get you. Indexing strategy, again, that's another hour-long conversation. But there's pros and cons to having too many indexes, too few. It's kind of an art, but definitely link up with the DBA and have that conversation if you think that indexing could help your queries for sure. All right, we're running kind of close on time, but I think we're going to make it here. Some other common things that we're talking about: stage table abuse. This is where I've got, a 1,000 query or 1,000 line query inside a stored procedure. It's doing a lot of data acrobatics because we're doing a lot of data transformation to get that end result. You see a lot of this process in specific reports where, you've got like maybe an application database that's also serving as a reporting database, but the application database by nature is not modeled in an analytical model, preferably. So what you see a lot of times is, instantly when you run this proc, it automatically grabs the data that it needs, models it, filters it, does all that and necessary work to get it to a proper reporting model, and then promotes that to the screen. If it's not talking about a lot of data, then it's probably not a performance pain point. But when you start talking about larger data systems with lots of users, you got to think about how much data you're requiring for this report. Are we locking any of the other users while we're bringing this data in and doing these unnecessary transformations. If that's the case, if you're, I see a lot of this where businesses will use their application database as a reporting database, and it starts to have a pain point because when reports are, heavy volume, certain things in the application start to become unstable. So if that's a situation, then we need to have the conversation of, hey, we need a reporting model. We need to get this reporting activity off the application database. Several different patterns there that we can adhere to, but that's a conversation that you'll want to definitely have if that's a problem. Merge statements. This is another component of the T-SQL language. Basically, it operates as an upsert, meaning that it's updating and it's inserting at the same time. Sometimes you might even have an extra delete clause in a merge statement. The reason why merge statements are nice is because they are elegant. They look clean. Let's take a look at what that looks like. Very simply, you're merging a target table using a source table on your join condition, and then we have the rules. When matched, do this. When not matched, do this. Some other thing, when not matched by source, then you can delete it. It's very elegant, it's very clean, but there is a time and a place for it. For example, this works great in ETL scenarios because it's a one-time use, hopefully off-peak hours. But the problem is when you start using merge statements as a default query pattern for your update insert operation, the performance pain there is that the way it locks tables. So take, for example, you've got a stored procedure or a family of stored procedures that have merge statements in to either update, insert, but those procedures are being called heavily, 1,000 times a minute. Well, that's a huge locking issue that could, be a huge critical point for your application. So I don't necessarily recommend using merge statements within application databases just because of the nature of the volume. They're perfectly fine for ETL scenarios. Again, it's one of those situations where it depends is the right answer. Typically, the rule of thumb is if you do have updates, inserts, and deletes, just even though they're separate statements, it's cleaner and more performant to call them out separately. If they're set-based, that is, obviously we don't want to do looping through here, but if you're in a situation where you've got a set of queries that are called a lot, 3 update, insert, delete statements is going to be more performant than one big merge statement if we've got a heavily transacted system. Table variables. These are things that can kind of creep up and you think it's not a bad idea, but unfortunately they're not as nice as they could be. Some gotchas here is that not all table variables exist in memory. There is a temp dependency there, a temp DB dependency. So that being said, there's also unreliable indexing when you need to join back to it. There's no statistics on the engine itself when we're using table variables. It's just more efficient to use the temp tables instead, especially if you have larger, data sets that you're maneuvering. It's just one of those things that's a best practice. Not, it's not a crime. You can still, not saying to go rip out all of your table variables, but if you notice that you do have some performance issues there with some, temp DB contention, then you can utilize this technique here to kind of alleviate some of that. Table valued parameters is another one of those things that can be easily overkilled. And basically what we're talking about here, say we have our own created type, and it's going to be a data set type. We're creating a type as a table. It's called category table type, and it's got these 2 components to it, these 2 attributes, an ID and a string value. So we've created a type. You can also send that type through stored procedures, which sounds great. You're sending all the data at once. The only caveat here is that when you're lifting data that could already be originated within that same procedure, you're kind of doing overkill. What I typically like is when you do need a set of data to start your procedure is to, send over just the values that you would need to originate that data. For example, in a situation like this, if it's originating in the same source, I wouldn't send this entire value over. I would send over maybe the ID because it's small as a footprint, and then have that procedure look up the rest of the values and then process the data accordingly. Now, sometimes that's not an option. Sometimes we're talking about two different systems, isolated over the web or something like that. And sometimes you have to send over an entire data set. That's fine. That's not what I'm talking about. But heavily overloading table valued parameters, that you'll notice that if you just use integers calls, minimal footprints, and originate that data within the proc, you'll notice some more efficiency there. So this is, things we just said. Why hop the data across the proc if it could easily originate within the proc? So let's talk about some sucker punches real quick. Indexing basics, we kind of already talked about this. Like I said, you can have too few indexes, you can have too many indexes. We've covered what a table scan is versus a seek. Like I said, indexing basics, if you can kind of spend a day, kind of go over and over the highlights of how to index a set of tables, it'll really yield a lot of good value results to your programming, because you'll be able to craft queries and make recommendations to the DBA on more performant queries as well. The DBAs are your friend here. They want you to write performant queries, so they should definitely be open to that conversation. GUIDs is another sucker punch that I kind of see out in the wild. Not that it's, not that they should never be used, but I see them used as the primary key of the table, which is a clustered index in SQL Server. It's a larger data footprint, so you've got a larger, you've got a larger form factor on your index versus a small int value. Not that they're completely unnecessary. You shouldn't ever use them, but just don't make them your primary key. I know they're great. They serve a purpose. They can have uniqueness to them. But if you have like a surrogate primary key instead, just like a regular integer value number to help kind of augment your GUID, that way the performance will be a lot better. Anytime you've got large footprints of data within your index, you have what they call page splits. So when enough data gets written to the table, those 8K pages, they have to split to hold all that data. So if you can keep it lean, that's a nice little trick there. CSV columns. This is storing sets of data as a string. I don't see this too often, but I do see it. This is where key value pair tables it's a much better option. You can join on them. You don't have to parse out the values. This is just something, so if you do see this in your data, there's a more efficient way to store this type of information. Naming conventions. A lot of people think naming their stored procedures SP underscore is a best practice, but actually SQL Server uses that as a named prefix. So if you are calling out a stored procedure with SP underscore, when SQL Server goes to look for it, it has to go and look through its existing SP underscore. When you do new stored procedures, if you've got the ability to do your own naming convention, name it something else, like USP, user stored procedure, or something like that. That'll help alleviate that extra lookup that SQL Server is doing. Cascade deletes. This sounds great in theory. A lot of work has to go on under the covers here. I'm a big fan of having this type of logic built into the stored procedures or the code itself, and not letting the database manage the referential integrity. It's kind of a slow process. That's not to say don't have your keys. Your keys can manage the referential integrity on that level, but just don't let your database schema itself define the deletes and stuff like that. So we've gone through a lot of material in a short amount of time. I hope everybody was able to get some good feedback here. I do have some tidbits here as far as resources. There's a website called Statistics Parser that somebody in the community built. That messages tab, when we set the statistics time and IO on, you can paste that in this box and it gives you a nice tabular format. This is a great tool to use. Justin, if you wouldn't mind sending that in the chat window, that way everybody can get a copy of that. Here's a query here from, this is one of my favorite blogs, blog.sqlauthority.com. just a wealth of information on this site. This is a very valuable query to have because you can find your top 10 most expensive queries based on various attributes. This is a great query to have in your tool set to see if anything you wrote might be one of the most offending queries on the server. It's good to kind of head that off at the pass. Here's another great tool that's a community-driven SP Blitz. It's a family of stored procedures that helps find server issues, but I really like the indexing aspect of it. It allows you to do sort of like an indexing maintenance and analysis on your family of indexes to see if you've got too many, too few. You can get poor performing query information from this as well. So if you're not already using that, this is also a good tool to kind of explore to have in your toolkit. Search procs for specific design patterns. Say you want to look over your family of stored procedures in a database. This is a good query here. So if I'm looking for merge statements, I can put merge in the search term right there. Or if I'm looking for loops, I'll put a while or a cursor in there, and that will identify all procedures that might be offending, iterative processes like that. So this is a very valuable query, kind of have in your tool belt. You can use that a lot as well. Justin, I think that wraps us up. Do we have any final thoughts or parting questions?
I don't have any more questions. I posted all of the links to everything if anyone wants to save those.
That's fantastic. Thank you. Well, guys, thanks for spending the time with us today. This has been a fun conversation. Feel free to reach out to us. If you want to carry this conversation further, we love talking about this stuff. Data is a huge passion for the data services team here. So if there's a series of questions or maybe a thought process you want to explore deeper, would love to have that conversation. Thanks, Justin.